All right, nerds, so let's get our chemistry on. We'll start with particle theory because that's the basics of everything. And then as we go on, we'll get more and more complex. But we really are going to build upon each previous lesson as we go. So if you miss one, make sure you go back and catch up before we move on. Um, what's the point of today? Well, first off, we're going to explain particle theory as a model for matter, and that's actually really important that you understand, particularly with chemistry, most of the things we're talking about are models. Okay, so they're the way we explain reality as best we can. Then we're going to revise the physical properties of each state of matter. Okay, so particle theory. What is it? What does it mean? Basically, matter is anything that takes up space. Um, Anything and everything around us in the universe can be classified as either matter or energy. Okay, so that should be an or there. So what is the particle theory of matter? It's got 6 components. First, matter is made up of tiny particles, and these are atoms and molecules. Particles are in constant motion. Even in a solid, they're still moving. Particles of matter are held together by both strong electric and nuclear forces. And there are empty spaces between particles, which are actually much, much larger than the particles themselves. Each substance has unique particles which are different to the particles of other substances. So, for example, the particles of hydrogen are not the same as the particles of oxygen. And the particles of water, which remember up here it says it can be molecules as well, so we treat them all as particles. The particles of water are not the same as the particles of carbon dioxide, or even more importantly, the particles of water are not the same as the particles of the hydrogen and the oxygen particles which make up the bigger particle. Temperature affects the speed of the particles, so the faster these particles are moving, the higher the temperature, the faster the particles are moving. And generally, this means they'll hit each other harder, hit each other more often, and this results in chemical reactions. These collisions result in chemical reactions. Okay, so what are our properties of each state of matter? Okay, so this should be largely revision. So we've got solid, liquid, gas. We're not going to worry about plasmas as such. Now, the shape of a solid is fixed. The shape of a liquid, it takes up the shape of its container, which means it's indefinite. A gas has the shape of its container as well. The volume of a solid is definite. Okay, it has a set volume. The volume of a liquid is definite. But a gas, if we take half a liter of gas and then we put it into a 3 liter container, it will fill up that container. So the volume can change. The volume is indefinite. Ability to flow. No, solids can't flow, but your liquids and gases both can. Solids and liquids can be compressed slightly, but gas is easy to compress. If you want to test this, we'll go with a syringe, fill it full of liquid or solid, and it's tough to compress, but fill it full of gas and you can probably push it most of the way down. There's a very small change in volume when we heat something up that's a solid. That change in volume will increase as a liquid, and as a gas, the volume that it's able to change to will increase quite a lot. If you ever want to see this, put a half-filled balloon in front of a heater and it will expand quite a lot, much more than any other solid will. Okay, so these are the diagrams. You should know these diagrams. You should be able to reproduce these diagrams if you were asked. Okay, so the solid, fixed shape, fixed volume, container takes the shape of liquid takes the shape of the container. It says here free surface. This means it'll have one surface that's not touching the sides of the container and a fixed volume. Whereas the gas, it doesn't have a free surface because every surface is touching all edges of the container. Now these changes, so if we change from one to the other, it's down to energy. So if we've got a solid, if we add energy to it, it will become a liquid. If we add more energy to it, it will become a gas. If you add yet more energy to it, it will become a plasma. which are actually quite common. We see this all over the place. In fact, plasmas, even though we rarely talk about it, it is the most common state of matter in the universe. It's just on Earth, it's not the most common state of matter. So, yeah, it's all very interesting. Anyway, that's our first lesson, and we'll move on, and away we go. All right, see ya.